Hi, welcome to our math. Today I'm doing a series of videos on matrices, specifically adding, subtracting, and multiplying. In this video, I have a subtraction problem, but each of my two matrices has a scalar multiplier. The scalar means it's just a simple number. I know it doesn't look simple because they're both fractions. That's okay. The thing is, 1/2, 1/5, if we divide, we would get terminating decimals that are pretty easy to manage, but because we are in math world, we are going to keep all our numbers as fractions, and we're going to do the addition subtraction of fractions by finding our common denominator. It's a good refresher for basics in math that you should have already mastered. Okay, so the first thing I'm going to do is multiply all of the elements in the first matrix by 1/2. If I think of 3 as being 3 over 1, I see that when I multiply by 3/2, I do 1 times 3 is 3, 2 times 1 is 2, and I have my fraction. Okay, for all my even numbers, I'm just dividing it in half. -3, 4, 6, and 7. 11 much like 3 is going to become a -11 halves. Okay, now it says minus. I don't like subtracting matrices. I don't like subtracting matrices because I find you will subtract the first few elements fine, but as you work through the matrix, you will stop subtracting, start adding, and everything goes awry. So what I'm going to do is I'm going to say plus and multiply through by a -4/5. Okay, -4/5 times 0 is 0. Here's where it gets interesting. When you multiply a fraction by a number like 10, if we imagine this as being 10 over 1 or 6 over 1, what we are doing is we are multiplying the 10 by that 4. So -4 times -10 is 40. When we divide by 5, we get an 8. But when you multiply the numerators first, you sometimes get really big, kind of ungangly numbers that are not as easy to manipulate. So I prefer to divide first. If I do the division first, -10 divided by 5 is a -2, and -2 times -4 is that same 8. All right, 5 divided by 5 is 1, -4. 5 doesn't go into 6, so this is much like that 1/2 times 3. The numerators multiply, the denominators multiply. I end up with a -24 over 5. Here I end up with a 12 over 5, and this one becomes a -28 over 5. Okay, so now that I've done the scalar multiplication, I come to the fun part, which is adding them. So let's start with the easy elements. 3/2 and 0 is 3/2. -3 and 8 is 5. 4 and -4 is 0. Everything else has a fraction. So I'm going to put the 6 over 1, the 7 over 1, and I need to get a common denominator. Because all of these have a denominator of 5, the first thing I'm going to think about is multiplying all of these fractions by 5 over 5. The reason I multiply the fraction by 5 over 5 is 5 over 5 is equivalent to 1. That multiplicative identity of 1, anything times 1 is itself, sounds boring until you realize that you can be creative with your 1. In this case, it's going to be 5 over 5. If we multiply this out, I get 30 over 5 minus 24 over 5, which ends up as 6 over 5. For my next one, 7 over 1, this becomes 35 over 5 plus 12 over 5, which is a 47 over 5. The last one is the trickiest. If I do the multiplication, I get a -55 over 10. I now have the correct 5 in this denominator, but I need to bring this 2 over here. I need to multiply this fraction by 2 over 2. So I'm going to get a -56 over 10, which is going to give me a -111 over 10. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.